Okay, now we're going to talk about applications of radical equations or word problems. Now, the good news is you don't have to write these word problems. And the other piece of good news is there are two ways of solving them. Now, the first method is solving for the variable you are interested in and substituting in the information you're given and answering the question. Now, I will use this method. Even if a radical word problem mentions the word inverse, you don't need to go find the inverse. Just use this method that I'm going to talk about in these two examples. So let's get on to the first example. In example 1, which is a problem from your review, there's this word problem about the end of a star's life, and it reads like this. Near the end of a star's life, the star will eject gas, forming a planetary nebula. The Ring Nebula is an example of a planetary nebula. And then you get given an equation that has an exponent in it. And we see the equation for the volume of the nebula here in the problem. So you get given the equation where V is the volume and T is the age in years of the nebula. Now, you may be asked to write the inverse model that gives the age of the nebula as a function of its volume. Now, you could go find the inverse of this equation, or you can use the method that I will show you here. You're going to solve for T. So, no numbers yet, you're just solving for T. Now, you know how to undo a cube. You're going to use cube roots. So, here we are. We start with the equation we're given. V is equal to 9.01 times 10 to the 26th power times T cubed. So we'll divide both sides of the equation by 9.01 times 10 to the 26th power. We don't try to figure out what that is yet. We just put it there, exponent and all, in the denominator. And now we have T to the third power on one side of the equation, which means we can take the cube root of both sides of the equation and solve for T. So now we have the cube root of the expression V divided by 9.01 times 10 to the 26th power. You notice I still didn't put that exponential expression in my calculator and try to figure out what it is. In fact, it will blow up your calculator if you try to do that. I just leave it like it is. So that's step 1. I have solved for T. Now the next thing I might be asked, or that you might be asked on a test, is to determine the approximate age of the Ring Nebula, given its volume. Now, we get given a numerical expression for the volume. So, I'm going to place the numerical expression 1.5 times 10 to the 38th power in the cube root, and I put that entire cube root in my calculator, and now I come up with a number I can handle. It's 5501.175, and it has a lot more digits than that after the decimal point, but I rounded them. And now I have solved for T, the age of the Ring Nebula. So let me go back and review what we did. We started out with an equation V is equal to 9.01 times 10 to the 26th power times T to the third power. I solved for T by dividing both sides by the number and then taking the cube root of both sides. And that means I have T, which represents the age as a function of volume. And then I use that equation, which is an equation for the age, to answer the ultimate question, which is, what is the approximate age of the Ring Nebula? And I do that by replacing V with the numerical expression that I'm given and figuring out what the answer is with my calculator. Let's go to the second example. In this one, we get given some information about the population of an island. Now, this is very similar to a question you will see on the test. Now, the population is represented by 3.32 t to the 5/3 power. So this time we have a fractional exponent. And so I'm asked if the population is 45.34 million, how much time has passed? How many years have passed? So I'm going to begin by solving for t. Now, by now, I hope you know that to solve an equation with a fractional exponent, the first thing I have to do is isolate the exponential expression. So I divide both sides by 3.32. And then I got to get rid of that exponent, 5/3. How do I do that? I raise both sides of the equation by the reciprocal of my fractional exponent. That means I flip the exponent. So I'm going to raise both sides to the 3/5 power. That gets rid of the exponent on t, and now I have an equation for the time that's passed, the years that have passed, t. Now, my original question was, if the population is 45.34 million, how many years have passed? So I am going to substitute in 45.34 million, or 45.34 for P, and use my calculator to figure out what I get if I raise 45.34 divided by 3.32 to the 3/5 power, and the answer is 4.8 years. So you see, you can use inverses, but it gets a little confusing. If you just solve for the variable that you are interested in, that you're being asked a question about, and then substitute in the numerical information you've been given for the other variables, you'll be fine and be able to answer all of these questions very easily. Now, if you have questions, come see me in the morning. I'll be there at 8:15 or maybe even a little earlier if you can get in the building to answer your questions. And I will also go over this again before we take the test. I'll see you in the morning.